Hello everyone, this is Unit 2 Lesson number 2. By the end of this lesson, you should be able to generalize basic number patterns to a method for finding the nth term in a linear number sequence. Without further delay, let's get started. Okay, let's consider the sequence given above, where the first term is 1, second term 5, third term 9, fourth term 13. We can organize this sequence into a table to help us with notation and writing a generic rule. This is a rule that will help us to find any term within the sequence. Let's take a look at the table below. So n is the term number, and 4n minus 3 is our general function rule. Let's talk about how we get that. So first of all, we know our first term from the sequence above was 1, second term 5, third term 9. Our fourth term, of course, as we saw above, was 13. You can see within this table that we are increasing from term to term by 4 units. We are adding 4 units to the previous term to get to the next term. So if I added another 4, of course, that would make the fifth term 17. So how can we write a rule to allow us to find any term, right? Any term, like, for example, the 100th term. Okay, I don't know what that term would be yet, but I do know that I can find a rule to do so. Notice that this sequence follows a linear nature. By linear, I mean it's increasing by the same amount each time. So if I had to add 4 units to get to this term, where the sequence term is 1, our 0th term, which is a key term, would be -3. So if I were to graph this, I could come up with a function rule from the graph in order to help us determine any term within the sequence. Let's look at the next slide at the graph of the sequence. Okay, just like we did completing the table previously on that previous slide, I knew that the following points, or sequence and terms, were applicable to this situation. So if I had to graph these points, for example, the point 1, 1, and the point 2, 5, and the point 3, 9, I think I've got a problem there. Yep, I definitely do. I put that at 4, 9. So 2, 5, and 3, 9. That would make for us a linear function, which would have a y-intercept when x is 0, that y is -3. Now, this is not x, this will be n. N is equal to 0, and we're going to call this f of n. So our function rule, based on the number of terms, can be written as followed. So if I were to write an equation for this line, I could just take 2 points, find the slope between 2 points. So I could go up 1, 2, 3, 4 over 1. So that means the slope of this line is 4. And the y-intercept I can see is -3. So to write an equation for this line, I would take the slope, which is 4, times the independent variable, which in this case is n, and subtract 3. And you guys, that's how we get our sequence rule. This is clearly a linear function, therefore we can write a linear equation, and then in turn, turn it into function notation. All right, we're going to look in the next slide, and slides to come, on how to use function notation. Let's move on. Okay, before we get into how to use function notation, let's look at what this rule looks like, and then how we can determine some of its attributes. So what about this function rule makes it linear? Well, we talked about that previously. We said that to go from one term to the next, you add 4 units. So if I'm adding 4 units, that's going to represent my slope. Okay, and of course our 0th term represents, when we talk functions, that represents our y-intercept. Okay, so when a sequence increases or decreases by the same amount each time, we say it has a linear pattern. Okay, it has a linear pattern, and it results in a linear function. Okay, whether that's an increase by the same amount each time or a decrease by the same amount each time. Let's look at further applications of linear functions on the slides to come. Okay, so the equation of a line can be written in the form y equals mx plus b. If we rewrite this function in function notation, then we would write it in this notation f of n equals mn plus b. On a graph, m is just the slope, like we mentioned earlier. In a sequence table, okay, so in a graph of a line, m represents the slope. In a sequence or table, that m represents what's called the common difference. Okay, it's what the function or the sequence changes by as you change from term to term. Okay, let's continue. All right, so again, looking at the table and the graph, what does the 0 term represent? Okay, on the graph of a linear function, b represents the y-intercept, right? I guess I could try to spell y-intercept correctly. Okay, there we go. In a sequence or table, b is that starting value, or the 0th term. Okay, those are synonymous based on what form they're in. Let's see how to use those in the slides to come. Okay, here let's practice writing a couple function rules. Okay, I'm going to look at example 1 here, where my first term of the sequence is 2, second term of the sequence, -3, third term of the sequence, -8. Can you see a common difference? It looks like each time we're subtracting 5. So if I subtract 5, I should get -13, -18, -23, -28, -33. Now to get the 0th term, I would actually have to add 5 to go back, which would give me a +7. Okay, now when we're identifying the function rule, I want to look at 2 items. I want to look at the 0th term, and I want to look at the common difference. And therefore, my function rule, oops, let's go, this would be a better idea. There we go. Our function rule, f of n, would be our common difference times our term number, and in this case, plus our starting value, or our 0th term. I could then find any term number that I wanted to. If I wanted to find the 100th term, I would plug 100 in for n. Okay, let's look at the second example. Looks like I am adding 1 to any term to get the next term. Okay, so that would give me the following values. Okay, so our common difference is going to be a +1, and our starting value, or 0th term, should be -5, because if I add a 1 to -5, I would get a -4. You could pause the video, write your function rule, and then come back and check with me. Okay, so our common difference is 1 times our term number, and then we add on our 0th term. There's our function rule. This function rule could also be written as f of n equals n minus 5. So if I went out to the 100th term, right, what would that term be? Well, that term would be whatever n minus 5 is. So the 100th term would be n, which is 100 minus 5. So that sequence term value, or the 100th term of the sequence, would be 95. Okay, let's look at a few more examples. Alrighty, let's take a look here at another type of example. The y-intercept, or starting value, can also be found by solving an equation. Let's start by finding the constant difference of this particular sequence. It looks to me like our constant difference is 3. Okay, so our slope of a linear function, or our constant difference, would be 3. Then we're going to pick an ordered pair to plug in using algebra to find b. So, for example, let's write a general formula for our our sequence in this case? Well, I know that the common difference is 3 times n plus this unknown value b. I'm going to pick any one of these numbers, these ordered pairs. So I have 3 ordered pairs that are given to me. The 10th term is 25, the 11th term is 28, and the 12th term is 31. I could pick any one of those to use. I'm going to choose this. These numbers seem nice, 10 and 25. So that tells me that f of 10 is actually equal to 25. So if I plug in a 10, I get out a 25. So I'm going to get a 25 if I plug in a 10. Now that's going to allow me to only have one variable now. Therefore, I get 25 equals 30 plus my initial value, or my 0th term. Thus, I can subtract 30 from both sides. That gives me -5 is equal to b. Okay, that allows me to do 2 things. First of all, it shows me what my initial value would be, the 0th term. And it tells me my function rule. All right, so my function rule now, f of n, is going to be my common difference, 3 times n, and then take away, or in this case, we're going to add a -5. Okay, now I can fill in the rest of the table. I'm going to add 3 to this value, which will give me a -2. And now, at least for the time being, I've filled in all the criteria within this table. So my function rule, like I said, is my constant difference, and I add my 0th term. Okay, let's look at another example. I'd encourage you, within any video, to pause when you think you're at a point where you understand, attempt a question, and then let the video run. So I'm going to complete the table here for the following and write a function rule. Okay, I see here common difference of 3. I'm going to add 3 all the way down the line and come up with a function rule. Now I'm going to take away 3 to get the 0th term. That'll be a -2. My function rule then in this case would be common difference times n, add that initial or 0th term. That's my function rule for this sequence. Now I could confirm that that's true. All right, the 8th term should equal 22. So I'm going to plug in an 8 for n and see if the 8th term comes out to be what I've projected it to be. It's 24 minus 2, which, go ahead and look, that's 22. So my function rule is accurate. Let's continue. Okay, second example, go ahead and write a function rule for the sequence and use it to find the 50th term. I'd encourage you again, pause the video, come up with a function rule. That function rule is going to be for the nth term, and we're going to use that rule to find the 50th term. Okay, now you're back from attempting this question. 2 things that I need. First thing, I need the constant difference. The constant difference looks like a -5. Okay, I also need my initial value, or my 0th term. So I'm going to work my way back to that 0 term. Okay, so I'm going to add 5 to -3, gives me a 2. Add 5 again, that gives me 7. Add 5 again, that gives me 12. So my 0th term is 12. So my function rule should be the constant difference times n plus the 0th term. That is my function rule, -5n plus 12. Okay, now I'm going to use that to find my 50th term. So the 50th term of the sequence would be -5 times 50 plus 12. Okay, that's going to be -250 plus 12, which is -238. So my 50th term of the sequence should be -238. All right, we got one more slide. Let's get to it. Good surprise on this slide. We are done with this lesson. You do not need to do the lesson 1 and 2 homework quiz today. However, if you choose to, that's up to you. You'll get multiple attempts at that once you feel comfortable with both lessons 1 and 2. All right, guys, we'll see you in the next video. Have a good day.